This is the View Calc program. We're doing topic 4, which is the power rule and sum and difference rules. This is the second video in this series, and we're going to talk about what happens when you have a sum or difference of functions. So if you are adding or subtracting functions, only adding and subtracting right now, we'll talk about products and quotients in other topics like topic 5 and topic 6. If you want to differentiate f of x plus or minus g of x, you can just split the pieces apart and differentiate each individual piece, meaning the derivative of f of x plus or minus the derivative of g of x. You could also write that as f prime of x plus or minus g prime of x. So let's go ahead and look at example 4. We're going to do examples 4, 5, and 6 with this information. Again, right now you can't differentiate products and quotients as products and quotients. So when you are handed a product or a quotient, we're going to have to deal with that in a different way. So in 4a, we're asked to differentiate f of x equals x to the fourth plus 10x squared minus 8. So because this is a sum or a difference, in order to differentiate to get f prime of x, I literally just derived the separate pieces. That's it. So x to the fourth would be 4x to the third, right? Because I drop the power down in front and lower the power by 1. Plus 10x squared, well, that 10x squared is going to become a 20x to the first, or just a 20x, because I drop the 2 down in front with the 10. 10 times 2 is 20. And then I lower the power by 1. And remember that the derivative of any constant ends up being 0, so I don't even have to write it if I don't want. So my answer is going to be that f prime of x is a 4x cubed plus a 20x. Now, if we look at 4b, same concept. I only have the two terms, right? So my f prime of x, they're being added or subtracted, is just the derivative of each of these pieces summed together, basically. So the derivative of 20x to the fifth will be 100x to the fourth, because I drop the 5 down with the 20 and lower the power by 1, plus a 3, right? Because this would be, it's a 3x to the first. I drop the 1 down in front, so it's 3x to the 0, which is just a 3. So that's my answer. That's my example 4. Now we're going to get things a little bit harder in example 4 and 5. 5 and 6, rather. So in example 5 and 6, even after I just expressly told you that you don't know enough to derive a quotient or a product as it is, I'm going to give you some quotients and products, which is, totally a responsible adult thing to do after telling you don't know how to do it. So in 5a, I'm going to give you f of x equals x squared times the quantity 5x plus 8. And in 5b, which is definitely the harder of these two, I'm going to give you that f of x is 3 square root of x times this 2x squared plus 5x minus 4. Okay, cool. So here's the issue. You're going to learn how to differentiate products in topic 5. But although these are products, this is an x squared times this whole parenthesis, they're very straightforward to simplify, and then they will no longer be products. Where we're going to end up using this product rule in topic 5 is when we have functions that we either can't or shouldn't simplify. So I'm just going to distribute this and make it no longer a product. So see how this is currently a product? It's an x squared times some other stuff. If I distribute the x squared, it won't be anymore. It'll be a 5x cubed plus an 8x squared, which I can now differentiate. So my f prime of x is going to be, if I differentiate this 5x cubed plus 8x squared, is going to be a 15x squared, right? Because I dropped the 3 down in front, so 15x, and then drop the power by 1, plus a 16x. And there's my derivative, right? I have differentiated. So now 5b is going to be a little bit harder, mostly because we love fractions. Everybody does. So this is actually a 3x to the 1/2 times a 2x to the second plus a 5x minus a 4. When I distribute this, right, because currently it's a product, but if I distribute it won't be, it'll be simplified, I'm going to get a 6. When I add 1/2 to 2, that's the same as a 1/2 and 4 halves, so it's going to be 5 halves. So this is going to be 2x, or 6x to the 5 halves, plus a 15 x to the, when I add 1/2 to a 1, that's a 1/2 plus 2 halves, so that's to the 3 halves. And I'm going to get a minus 12x to the 1/2. So as much as that's not super fun, I can go ahead and derive now. So I didn't mean to put a prime. My bad. Sometimes we do that by accident. Didn't derive yet, right? So now I'm going to differentiate, right? I did not mean to put a prime up there. My bad. Sometimes those things happen. So now I can differentiate, and my f prime of x is going to be, I'm going to drop the 5 halves down in front. That's going to give me 30 halves, which is a 15. So f prime of x equals 30 halves, or 15, x to the, when I subtract 1 from 5 halves, that's 5 halves minus 2 halves, right? 1 is the same as 2 halves, so I get 3 halves. When I go ahead and drop this 3 halves down in front, it's 3 halves times 15. Well, that's a 45 halves. X to the 3 halves minus 1 is a 1 half, right? And then when I drop this 1 half down in front, I'm going to get 12 halves, which is 6. X to the negative 1 half. And sure, you could put the x to the negative 1 half on the bottom if you really want, but especially in a problem this long, I don't think it's really worth it. Excuse me. So I get f prime of x equals 15 x to the 3 halves plus 45 halves x to the 1 half minus 6 x to the negative 1 half. Cool. The last thing we're going to do is example 6, and then you'll have 7 practice problems to try. Okay? So let's try example 6. All right. So in example 6, same idea, still finding f prime. We have f of x equals a 5x squared plus a 3x minus a 7 all over an x. And for 6b, we have f of x equals a 3x cubed plus a 2x plus a 5 all over the square root of x. Okay, so in both of these, I have a quotient, right? And remember, I specifically said that you don't know how to deal with quotients right now. So you're going to have to find a way to write this so it's not a quotient. So there are 2 ways to think of this, okay? And I'm going to buy myself a little bit of space because I might need it for 6b. We'll see. Okay, so there's 2 logical ways to think about this. You can either, because this is a monomial, right? This is a monomial, it's a single term. You can think about it either by flipping that up and making it multiplication by x to the negative first, which is totally fine. And then you could distribute, and when you distribute this, it's going to lower all the powers by 1. So you're going to get that f of x is 5x to the first plus 3 minus a 7x to the negative 1, and then you could take the derivative. You could differentiate and get a 5 plus a 0, right? Because this is an x to the first, so it would be 1 times 5, x to the 0, which would just be 5. Constants always derive to 0, and this would be a negative 7x to the negative half, or negative second, rather. So one option is to do this, and you could write this as a 5 minus 7x to the negative second, or you could write it as a 5 minus a 7 over an x squared. That's fine, right? Either of those would be great. The other way to think about this, if you don't like that product idea, and this is the way I usually think about it, is instead, I usually get here by splitting this into 3 separate fractions. 5x over x plus, 5x squared over x plus 3x over x minus a 7 over x. And that's going to get you to the same spot that I was right here, okay? I'm going to get 5x squared over x, which would just be a 5x. 3x over x would just be a 3, and this will be a minus 7x to the negative first. So you'll notice that that gets you to this same exact spot, and then you would differentiate the same way. Either of those is totally fine. Again, it sort of just depends on how you think about it. If you'd rather think about this as flipping this up to the top and multiplying, or if you'd rather think about splitting it into division. I will say that this multiplication idea probably works better for what we're about to do in 6b, but they're both pretty much the same thing. So I'm going to buy myself some space for 6b because 6b is not small. All right, so for 6b, and actually let me recopy it where we have a little bit more room. So 6b, we have that f of x is 3x cubed plus 2x plus 5 all over the square root of x. So again, there's 2 ways to think about this. You can either think about this as this guy is actually an x to the negative 1 half, right? He's the 1 half because of the square root, and he's negative because he's on the bottom, right? And you could distribute that to the 3x cubed plus 2x plus 5 if you want, right? So if you did that, you'd get that your f of x is equal to 3x to the... So 3 is the same as 6 halves. 6 halves minus a half would be 5 halves, so 3x to the 5 halves, plus 2x to the 1 half, right? Because this 2x to the first, well, 1 minus a half is a 1 half, right? Plus a 5x to the negative 1 half. And that's fine. The other way to get to this same spot is if instead you had split up, so if you didn't like that, you could have split this up into 3 fractions and you would have gotten to the same place. It's just a little bit different, right? So the other way to get to this same spot would have been if you had split this into 3x cubed over root x plus 2x over root x plus 5 over root x, right? remember that these are 1/2 on the bottom, so this would be a 3x to the 5/2 because it would be 6/2 minus the 1/2 power, plus a 2x to the 1/2 because it would be an x the first minus an x the or a 1 minus 1/2, and then plus this 5x to the negative 1/2. So you see, it gets you to the same spot. Either way, you're here before you differentiate. So now we can differentiate, and we're going to get f prime of x equals, when I drop the 5/2 down in front, I get 15/2 x to the 3/2, right? Because 5/2 minus 1 would be 5/2 minus 2/2, so 3/2. Plus, this will just be a 1 because it's 2 times a half, so 1, x to the negative 1/2, right? Because that's what 1/2 minus 1 would be. Minus 5/2 x to the negative 3/2, right? Because if you have negative 1 and you take away 1, that's negative 1/2. So you have negative 1/2 minus 2/2, which is negative 3/2. So this answer's fine. You could simplify it if you want, but that answer's totally fine. So again, right now you don't know how to deal with products and quotients other than to simplify them so that they're no longer products and quotients. So you're going to try practice problems 1 through 7 now. And that's kind of the deal.